So today I will give an example on how this gases law works. So we already discussed naman what are these types of gases. So today I will give an example of a Boyle's law and the Charles law. So as we all know that a Boyle's law and a Charles law is one of the law of gases. And for Boyle's law, we will use this formula, which is P1 multiply to V1 equals to P2 multiply to V2. So which means 1 is the initial and the 2 is the final. So sometimes or the other sources use Pi multiply to Vi equals to P final multiply to B final. So it's also the same, or the same lang gihapon ang way sa paggamit ana, even though the other sources use I and F. So because 1 is for initial and 2 is for the final. So as an example, a fixed amount of a gas occupies a volume of 1 liter and exert a pressure of 400 kPa or on the walls of its container. So which means we have the initial pressure and the initial volume. So what would be the pressure exerted by a gas if it is completely transferred into a new container having a volume of 3 liters? So as you can see, we have our initial volume and our initial pressure, and what we are going to solve is the final pressure. Why? Because what would be the pressure? So from the word, what would be the pressure exerted by a gas if it is completely and the new container is or has a presence of 3 liters, which is our final volume. So first, we're going to write the given. So we have the V1. So our initial volume is 1 liter. Then we have the initial pressure, which is 400 kPa. Then our final volume, we have the 3 liters. Then we are going to solve for the final pressure. So which means the final pressure ang ginapangita sa ato ang problem. So okay, let's solve this one. So as a formula, di ba itong kaganina that we have P1 multiplied to B1 equals to pressure final and multiplied to volume final. Ang ginapangita diri is the pressure final. So P2 is equals to pressure 1 multiplied to volume initial or initial volume divided to our final volume. So naa naman tay formula, so we can now transpose the given. So P2, write the initial pressure, which is 400 kPa multiply to our volume, which is 1 liter, and then divided to our final volume, which is the 3 liter. So since it is the pressure that we are looking for, so we can cancel out the liter. So 400 times 1 is 400. So divided it to 3. So our final pressure is equivalent to 133.33 kPa. So this is our final answer. So we now locate or solve for our pressure. So which means that 400 multiplied to 1 liter divided to 3 liter is equivalent to 133.33 kPa. So, this is now our pressure. Kaya diba, as our given, our initial volume and pressure is present man, and also our volume, our final volume is present. Ang ano lang nato is our pressure. Siya lang ang wala. So, this example is an example of Boyle's law. Because we use the formula for Boyle's law. So, which is the P1 multiplied to V1 equals to P2 multiplied to V2. Compared to example, this is again an example of a Boyle's law. So, a gas exerts a pressure of 300 kPa on the walls of container 1. So, which means there is a container 1 that exerts 3 kPa pressure, or its initial pressure. When container is emptied into a 10-liter container, the pressure exerted by the gas increases to 6 kPa. So which means now that this container is emptied into a 10-liter. So which means we have now our final volume. That exerted a pressure of gas that increases into 6 kPa. So 6 kPa is our final pressure. So, find the volume of the container. So, as you can see, a gas exerts a pressure of 3 kPa. So, this is our initial pressure. When this container is emptied into 10 liter, so this 10 liter now is our final volume. So, because of this volume that is inserted or put into a container, the pressure exerted by the gas increases. So when it's emptied, so the gas increases or the pressure increases to 6 kPa. So we have now our final pressure. So which means na atong ginapangita is the volume, which is the initial volume. So first, we're going to write the given. So the given, our initial pressure is 3 kPa. Our final pressure is 6 kPa. And our final volume is 10 liter. So which means we are going to get or solve the initial volume of the container. So okay, let's solve. So, same formula that we've used kanina. We have the P1 multiplied to B1 equals to P2 multiplied to V2. So, since you're going to get initial volume, so we have now transposed, then divided it to initial pressure. So, yun yung gagamitin natin na formula to get our initial volume. So, after that, write the given. So, 6 PA multiply to our volume divided to our initial pressure. So, 6 times 10 liter. Then, divide it to 3. So, cancel out our pressure. Then, mabilin is our liter na unit. So, initial volume is equals to, yes, our initial volume is equivalent to 20 liter. So, that's what happened. So, 20 liter ang ato ang initial volume. So in this given, we already assume that the temperature and the quantity remain constant. So that's the reason why there is no other changes except lang that we solve for the initial volume. So this one is also an example of Boyle's law. So because we use the formula of Boyle's law. Our second law of gases. So we have the Charles law. So here are some example in real life. So hindi lang Charles law uses in order for us to solve problem, to identify the temperature, or to identify the pressure or volume. It is also happening every day in our life. So, hindi lang natin napapansin, but Charles' law is everywhere. Kumbaga, nangyayari siya even to me or on you. So, one of the example is in cold weather or environment, ball and helium shrink. So, sometimes yung mga helium balloon natin or yung mga bola natin or basketball na bola is nag-shrink siya or kumbaga nag-decrease ang iyahang gas from the inside. So, because of the cold weather or because of the cold environment, kumbaga mura siya ma-flatten or mabawasan ang iyahang pressure inside. Then the second one, in bright sunlight, the inner tubes swells up. So, that's what happened if it is very bright or it is mainit or bright sunlight or mainit yung araw. So, nag-swell up ang mga tubs. And then the third one, in cold weather, so as a human being, di ba mapansin ninyo as we, di ba sometimes we naga-jogging ta or naga-exercise ta in a cold weather, mamatingala ta nga nung maglisod ta o ginhawa because the human lungs decreases its capacity to perform during a cold weather. So, yan yung nangyayari if it is very cold. So, minsan, di ba, kayong buntag sa'yo or ka-down pa lang, di ba, tugnaw pumid ang ano-ana weather. So, sometimes, di ba, dali rata ka po yun if we do exercise or we did exercise or jogging because of our lungs that can't perform well because of the cold weather. So, for this Charles law, we all know naman that Philippines use degree Celsius for temperature. But for Charles law, we will use Kelvin in order to solve the temperature. Alam naman natin that Kelvin on how to solve N plus 273. So, yun yung gagamitin natin in order to solve for the Kelvin. So, Celsius plus 700 or 273 Kelvin. So, yun yung formula for us to solve the Kelvin. So, for our first example of Charles' law, as you can see that a Charles' law or formula for Charles' law is we're going to use initial volume over initial temperature is equals to final volume over final temperature. So, this is the formula for Charles' law. So, kaganina, for Boyle's law, we use pressure per volume. So, by Charles' law, we will use volume per temperature. So, as you can see, our first question, a gas occupies a volume of 400 centimeter cube at 0 degrees Celsius and 780 mmHg. So, our 780 mmHg, it is our pressure that is present in a gas. What volume in liters will it occupy at 80 degrees Celsius and 700 mmHg? So, which means that our torque or our pressure is 780 mmHg. And our initial volume is we have 400 centimeter cube. We have also our initial temperature, which is 0 degrees Celsius, and our final temperature is 80 degrees Celsius. So, diba, as we have discussed kanina, that for Charles' law, we will use Kelvin in order to get the we will use Kelvin for temperature in order to solve our problem. So, first one, we are going to write the given. So, for our given, initial volume, we have 400 400 centimeter cube. But our final volume is unknown. So, mo na siya nga ato ang pangitaon in liters. Then, our initial temperature, we have 0 degrees Celsius, which is 0 plus 273 Kelvin. So, it is equals to 273. So, we have now our initial temperature. And also, we're going to solve for the final temperature. So, you have 80 degrees Celsius. So, 80 plus 273 Kelvin. So, 80 plus 273. So, it is equivalent to 353 Kelvin. So, which means that naana tayo initial temperature and also we have our final temperature. So, we can now solve now for our volume. So, solution. So, we have our 400 centimeter cube over, which is 273 Kelvin, equals to our volume, which is unknown, over 353 Kelvin. So, transpose. So, volume 2, which is our unknown, write our initial volume multiply to 353 Kelvin divided to 273 Kelvin. So, ato ang cancel out ato ang Kelvin. Then, mabili nato is our centimeter cube. So, 400 multiply to 353. So, after that, you're going to divide. So, 400 multiply to 353 divide to 273. It is equivalent to 517.21 centimeter cube. But, ang ginapangita nato is liter. So, we're going to solve for example number 2. As you can see, it is very easy na lang because our volume is already in liters and our temperature is already in Kelvin. So, there's no need na to solve for Kelvin, or there's no need na to convert Celsius to Kelvin. So, all we have to do is write the given and find the initial volume. So, our initial volume is unknown. Our final volume is 6 liters. Our temperature 1 is 150 K. And our initial temperature is 100 Kelvin. So, by that, it is now easy for us to solve what is missing pag isulat nato ato ang given. So, for our solution, so V over equals to over, so write the given. So V1, V1 over 150K equals to 6 liters over 100 Kelvin. So, V1, 6 liters multiply to 150K over 100 Kelvin. So, cancel out the temperature. So, mabili na lang nato is the liter. So, now, we can now get our initial volume. So, 6 multiply to 150, then divide it into 100. So, our initial volume is Yes, our initial volume is 9 liters. So this is our final answer. And this example is also a Charles law. So, tong una natin na example, and this one is an example of Charles law because we use temperature rather than pressure. So, there are some parts given na sometimes dili nimo magamit. So, you need to check talaga if ang inapangita ba is Charles or Gay-Lussac law or Combines law or Ideals law or the other one, the Boyle's law. So by next meeting, I will give an example for the Gay-Lussac, the Combines law, and also the Ideals law. So that's it for today. Thank you and goodbye.